given this equation, this equation, our job is to find a partial derivative of z with respect to x and with respect to y. So when given this, picture this in your mind. You have a surface. When you have a surface, z will be a function of x and y, because for a given x and the y coordinates, you can jump to the height. This z here is the height. So picture this function diagram in your mind. When you differentiate it with respect to x, x would be a variable, z would be a variable. So when you come to differentiate z, you differentiate it as normal, but then you've got to times by the derivative of the partial derivative with respect to x, because z contains the variable. This is a variable here, and remember y would be a constant when you try and evaluate this. So for example, let's try and do this. Let's find the partial derivative of z with respect to x, So here you've got one block multiplying with another block. Is this block a variable or is it a constant? Well, we're differentiating it with respect to x. So this is a variable, z is a variable, y is a constant. So this thing here will be a variable. This block here contains a variable. Is this block a constant or is it a variable? Well, why is it constant? Why doesn't vary? So this here is just treat it as a constant. So when you differentiate this, just remember that this block is a variable, this block is a constant. So just concentrate on differentiating this. So when you differentiate this, it will then give you 6x, and this is just a constant. This is just a constant. So now the second block. So when it comes to the second block, imagine it as one block multiplying another block. So is this block a constant or is it a variable? Well, we are differentiating with respect to x. So this would be a variable, z would be a variable, this is a constant. So this here is a constant. And then is this block a variable? Does this block contain a variable? Well, it does. Look, z, because z contains x, which in turn makes it a variable. So looking at this block, this is a constant and this block here contains a variable. So when you differentiate it, treat this block as a constant. So let's imagine this as being a bubble here. So when you differentiate this, this is a constant. So, and when you differentiate e to the power of the bubble, it would just be e to the power of the bubble. But then you've got to times with the derivative of the bubble itself. So differentiating this, so differentiate it as if z was just a variable. So when you differentiate 4z, it would just be 4. But because z contains a variable, you need to times by the partial derivative of z with respect to x. So that's why you've got this thing here. Now differentiate the 5, it's just a 0. So now you've got one block plus this block equals this block. You've got 3 blocks. Your job is to get the partial derivative of z with respect to x. So take away this and then divide it by this. That will then give you this. So this is our answer. You can simplify this if you want. Okay. Next one. So now with respect to y. So now we need to differentiate it with respect to y. So in this case, x would be a constant. This here would be a variable. This here, it contains the variable, making z a variable. So remember, when you differentiate z, differentiate it as normal, but just remember, when it comes to z, stick the partial derivative of z with respect to y. Okay, so let's do this now. So here you've got one block multiplying with another block. This block here is a constant because x is a constant. This block here contains a variable. So so y is a variable. So when you differentiate it, this will be a constant, and then differentiate it with respect to y. That will then give you this. So now the second block, but then imagine this second block as being one block multiplying another block. This block here would be a variable because y is a variable. We are differentiating it with respect to y. So this block here contains a variable. Does this block contain a variable or is it a constant? You see, it contains z. Z is a variable because it contains a variable here. So when you differentiate this, just remember to times partial derivative of z with respect to y. So let's do this. We are currently at this block. We've got one block multiplying another block. This block here contains a variable. This block here contains a variable, so we have to use the product rule. So the product rule says differentiate the first, leave the second alone. So differentiate the first, which will be just the 2, leave the second alone, leave the second alone, and then plus, the second part of the product rule is plus, and then leave the first alone, leave the first alone, leave the first alone, and then differentiate the second. So differentiating the second, imagine this as a bubble. When you differentiate the second, it will be e to the power of the bubble intact, and then times the derivative of the bubble itself, which will be 4. But because z is a function of y, we need to stick partial derivative of z with respect to y. So that will then give us this whole thing here. When you differentiate the 5, it's just 0. And then now you've got one block plus this block here equals this block. So your job is to get this on its own. So take away this block, throw it on the other side, throw this on the other side, and then divide it by this thing here. That will then give you this. So this is your answer. Okay.